In this video, we're going to look at another example of improper integral and how to determine if it converges or diverges, and if it converges, what does it converge to? So the example we're going to look at is the integral from 0 to 1 of x natural log of x. So first we note that the reason this is an improper integral is that the function f of x equals to x natural log of x is undefined at 0. So first we want to graph this function to see what the integral represents. So we need to take the limit as x approaches 0 from the right of x ln of x. Let x approach 0 from the right. We have 0 times negative infinity, an indeterminate form. So we rewrite our function as natural log of x over 1 over x instead of times x. If x approaches 0 from the right this time, our indeterminate form becomes negative infinity over infinity, which allows us to use L'Hopital's rule, apply L'Hopital's rule. So we take derivative of the numerator, it's 1 over x. Derivative of the denominator, negative 1 over x squared. Simplify it, we have limit equals to 0. So now we want to sketch the graph of this function. There's a hole at the origin, and then this is what the graph looks like. For our x greater than 0, that shaded region there is the area that's represented by the improper integral. So we can see that it looks very highly likely that area is finite. And so we should expect the integral to converge. And the integral represents negative of the area because it's below the x-axis. So again, we expect the integral from 0 to 1 of x natural log of x to converge and to equal to a negative value, which means it's the area would be the absolute value of the answer. So let's rewrite this integral as a limit of proper integrals. So be limit as t approaches 0 from the right of the integral from t to 1 x natural log of x dx. So it becomes essential that we find the antiderivative of x natural log of x. And we do that using integration by parts. U is natural log of x. dv is x dx. du is 1 over x dx. And v is 1/2 x squared. And so the integral becomes the integral of x, antiderivative of x ln x, is u times v, 1/2 x squared natural log of x, minus the integral of v du, 1/2 integral of x squared times 1 over x dx. So we simplify that, and we have the antiderivative of x ln x equals 1/2 x squared natural log of x minus 1/2 times the integral of x dx, which is equal to 1/2 x squared natural log of x minus 1/4 x squared. We don't want to simplify this any further than this. Now let's return to the improper integral. From 0 to 1 of x natural log of x, it's defined as the limit as t approaches 0 from the right of the integral of t to 1 x ln of x. Now we know antiderivative of x ln of x, so this is limit t approaches 0 from the right 1/2 x squared natural log of x minus 1/4 x squared evaluated from t to 1. So let's plug 1 in. This is the limit as t approaches 0 from the right of 1/2 times 1 squared is 1. Natural times natural log of 1 minus 1/4 times 1 squared, which is 1. And then minus, let's plug t in. So this would be when we subtract 1/2 t squared, natural log of t, minus 1/4 t squared. And when we simplify that, natural log of 1 is 0, so this would be equal to minus 1/4 is a constant, and then minus the 1/2 limit as t approaches 0 from the right of t squared natural log of t, and then plus 1/4 times the limit t approaches 0 from the right of t squared. Of course, that limit is 0, the last one, and we only have to really work and determine the limit as t approaches. So again, this is what our integral equals to. It's negative 1/4 minus 1/2 limit t approaches 0 from the right, t squared natural log of t. We just have to evaluate that limit and we'll know complete answer. So let's look at the without the constant limit t approaches 0 from the right, t squared natural log of t. Again, t squared approaches 0, natural log of t approaches negative infinity. We want to change that indeterminate form to 1 where we can use L'Hopital's rule. So to do that, we take t squared in the numerator and write it as 1 over t squared in the denominator. Now our indeterminate form is negative infinity over infinity, and we can apply the L'Hopital's rule. So take the derivative of the numerator, natural log of t becomes 1 over t. Derivative of 1 over t squared is negative 2 over t cubed. We factor negative 1/2, and this is limit t approaches 0 from the right of t cubed over t, which is negative 1/2 limit t approaches 0 from the right of t squared, and that limit is equal to 0. And now we know exactly what the integral from 0 to 1 of x natural log of x converges to. Just as we suspected, it's a negative number. The integral from 0 to 1 of x ln x is equal to negative 1/4. In other words, the improper integral from 0 to 1 of x ln x dx converges to a negative 1/4